In this video, we're going to take one of our kinematic equations and solve it for a given variable. In this case, we're going to solve it for the variable delta x. I always like, when I'm solving these equations, to circle both the variable I'm looking to solve for as well as the entire term that that variable is attached to. A term is anything that's being multiplied or divided by that variable. This is what we initially need to get by itself. We want to get rid of everything else from that side of the equation. In this case, we need to get rid of the vi squared. Since they're being added together, we simply subtract it away. That will get rid of it. But an algebraic statement says that whatever you do to one side, you have to do to the other. Vi squared. Whatever you do to one side, you have to do to the other. We have vi squared minus vi squared. They cancel out and they become 0. What we have left, vf squared minus vi squared equals 2a delta x. 2 times a, make sure this looks like a times, not a subtraction, and delta x. Okay, continuing on. We still want to get this variable right here by itself. I'll switch to a different color that looks a little bit hard to see. Maybe something a little bit lighter. There we go. We want to get this delta x by itself. Since it's being multiplied by this 2 and this a, the best way to get rid of them is to divide them away. 2 divided by 2 is 1. A divided by a is 1, so we'll have 1 times delta x. In other words, all this cancels out. Whatever we do to one side, we have to do to the other. 2 and a. So, if we write this out, on the right side you can see all we have left is the delta x, the variable we were trying to solve for. On the left, we have vf squared minus vi squared all over 2a. And there we've done it. We've taken our original kinematic equation and solved it for the variable x.